The pressure distribution above a wing is determined by wing shape, the camber and the aspect ratio. When we extend the flaps, we change the camber and usually, but not always, the aspect ratio. For the same airspeed, more lift will be generated where the camber has been increased by the flap extension, so you would expect to see a change of pressure distribution as shown here. A side effect of this shift in pressure distribution is that the pressure difference between the upper and lower surfaces at the tip will be less, but bigger where the flaps have extended. This results in the vortices moving inwards, but this doesn't mean the induced drag reduces. It just means the downwash is generated inboard rather than at the tips.
They start at the time of year and the place of maximum heating as the sun turns to retreat towards the equator in late summer or autumn. In the northern hemisphere, of course, that is June to November, and in the southern hemisphere, that is December to April. Okay, let's now talk about the intertropical conversion zone, the ITCZ. The first slide here is just a time lapse. You can see the movement from west to east of the depression systems. And in the middle there is the intertropical conversion zone. The ITCZ is a zone where converging surface air meets near the thermal equator at a low level trough. And if on some charts you would see it marked as the FIT, that is the Front Intertropical, in a French way of describing the ITCZ. And associated with the ITCZ is unstable convective cloud and a lot of precipitation.
Right, then on to lights, and what we're going to do first is we're just going to talk about some basic aspects to do with lighting, and firstly what we mean by frangible. Now frangible is another word for breakable, and if you look at the picture of that light you can see that there's a base plate and then there's a top part which is the lens, and then it joins together, and you've got a little grub screw there to keep them together, but the joining area between the two is a natural weak point. So the idea is that if you're in your airplane or your helicopter and you come into contact with that light, the light will break easily. It'll break before your airplane or helicopter breaks. So it's really important that aerodrome lights are frangible, and that's part of their design. Obviously, the other thing you need to think about when you're designing aerodrome lights or helipad lights is that they shouldn't be too high, because if they are too high, then they are going to come into contact with the aircraft, with propellers, with rotors, etc.